Right, so let's set up the circuit. So we're going to arrange it as per the circuit diagram. So we start off just going to arrange the kit in a similar way to the circuit diagram there. So I've got my voltmeter, it's going to connect across my resistor. I've got my ammeter to go into my circuit, and now I just need to start connecting it up. So I'm going from the power supply into the resistor, from the resistor into the ammeter, and then from the ammeter back into the power supply. So I've got a loop here with the current going out of the power supply through the ammeter and the resistor and back to the power supply, and then finally I just want to measure the voltage, the potential difference. And I could use the power supply, but it's good practice to put a voltmeter into the circuit because not all power supplies actually give you a true reading of the voltage they're pushing out. Okay, so I'm going to start to take some results. Start off with, I've turned the power supply off, so I have 0 volts, and you can see I've got 0 current. What I'm going to do now is gradually increase the voltage, so I'm going to go up to ½ volt. Okay, so it's very difficult to get accurate readings, but what I've got is nearly ½ volt, and I've got a current of 0.05 amps. Okay, so what I do now is go up to 1 volt. I'm going to go very close as I can to, so 0.97. 1.4. So 1.5, and I've got 0.15. You probably can see that the current seems to be going up in 0.05s. Let's go up to nearly 2 volts. Okay. And that is 0.2. So I've now got my results here, and you can see that it seems to go up in a regular pattern for this resistor, that every time I go up ½ volt, it goes up by 0.05 amps. And what I can do now is divide the voltage by the current, which is Ohm's Law, to see if I get a relationship. Now I'm not going to do the first one because that would be dividing by 0, but I can work my way up through here. So 0.5 divided by 0.05 is 10. That is 10, 10, 10, 10, 10, 10, 10, 10, and finally 10. So in all of these, when I divide the voltage by the current, I get a value out here of 10. And Ohm's Law tells me that this is the resistance of this component. So this resistor here is a resistor of 10 ohms, okay? And you can see that it gives a very consistent result. Anyway, we're going to plot a graph of these results just to check what the graph looks like as well.